Continue from where we are left in the previous class. Actually, we were doing graphs, so I have included the slide of graph in this particular section, but perpendicular line and proofs is the today's section. So we will finish up that particular slide and move on to perpendicular line and proofs. So the first one, they're asking us to graph y equals negative 3 over 5x plus 4. Here we know the y-intercept is 4 and the slope is negative 3 over 5. Let's use these two and graph. So y-intercept is 4 and we know the slope is negative 3 over 5. So we can go 3 units down in y-axis and go 5 units positive in x-axis. So if I go 3 units down, I reach 1. And if I go 5 units to the right, I'll get coordinates as 5, 1. To get a line, we just need 2 points. So if you draw a line passing through these 2 points, that will be the required graph. Okay. Not drawn exactly, but I hope made my point clear. So this will be the graph of the first equation. So let's see the next one. We will try to do this one. This is not given in the y equals mx plus b. So let's get it into slope intercept form. So subtract x on both sides. I'll have negative 4y equals 12 minus x. Then further divide by negative 4 all throughout. That will give me y equals 12 divided by negative 4 is negative 3. Negative x divided by negative 4 is positive 1/4 of x. So this time the y-intercept is negative 3 and the slope is 1 over 4. Okay, let's do this. Let's graph this. Negative 3. So the y-intercept is negative 3 and the slope is 1 over 4. So go 1 in positive y direction, that is this way, and 4 on positive x direction in this way. 1, 2, 3, 4. So we have these 2 points, and if I draw a line, I get the equation of, I get the required equation plotted in this manner. We just need 2 points. Let's do one more. We have here y equals 2x. Let's further simplify and get it into the slope intercept form, which is nothing but here 2x. 2 times negative 2 is negative 4 minus half. So we got to simplify this further, which will give us, take LCM only for these 2 terms. You don't want for this. You just take a LCM for these 2. So you will have, otherwise you can take LCM for all throughout. It's okay. So if I take LCM all throughout, I'll have y equals 4x minus 4 times 2 is 8 minus 1 divided by 2. So further, I'll have y equals 4x divided by 2 is okay. You can just use this and try to plot. Have y-intercept as negative 9 over 2 and the slope as 4/2. So let's use this. I'll use this time green. So already I've used purple, so I'll just use green to plot. So -9/2 is nothing but 4.5. -4.5 as the y-intercept. -4.5. So this is where I'll have y-intercept. And I have a slope of +4/2. So I have to go 4 along y-axis and 4 along y-axis. So let's go 4/2. So which means if I go 4 units up, 1, 2, 3, 4, and +2, 1, 2. So this is the point. Okay. So the coordinates of this point will be 2, -0.5. Okay, 2, -0.5, and the coordinates of this are 0, -4.5. So this will be our graph. I have not been able to draw this straight using the stylus, but I hope I'm clear here. So let's see the next one. The last one, same way, you just have to convert this to a slope intercept form. Subtract 2x on both sides, you'll have 5y equals -10 minus 2x. Then further divide by 5 on both sides to get y equals -10 divided by 5 will give us -2 and -2/5. Okay, so this time we have y-intercept as -2 and slope as -2/5. So -2 and -2/5. So 1, 2, -2 and 5. 1, 2, 3, 4, 5. Repeat the same process to get those 2 points, and we have the graph. Okay. I hope I'm clear here how to get the graphs for the line equations. Okay, let's see the next slide. Well, coming to today's section, distance from a line and perpendicular proof. If you want to find the distance between a point and the line, you'll have to drop a perpendicular and then find the distance. Okay, let's read this slide. The distance from a point to a line is the length of the segment perpendicular to the line with one endpoint at the point and the other endpoint on the line. Okay. So same way to find the distance between parallel line, you'll have to find perpendicular line segment with one endpoint on each of the line. Okay, so what does that mean? It means that if I have to find the distance between point P and line A, I'll have to drop a perpendicular. I'll have to drop a perpendicular. I'm not sure if that is the perpendicular. Let's. And you have to find the distance between these two. You know the distance formula, and this is going to be -1.5 and +1.5. I'm not going to use distance formula and find the distance. Otherwise, I'll give you the coordinate. You can use distance formula and find the distance here. Okay, so find the distance between the point P and this particular line. If P is having coordinates of -4, 4, and this has the coordinate of -1.5 and +1.5. Okay, use distance formula and find the distance between these 2 points. I'll give you like a 30 to 40 seconds or a minute or so. Just find the distance and use chat once you have the answer. Okay, if you have your answers, please use chat. And you can use calculator as well. The formula is what? X2 minus x1 whole square plus y2 minus y1 whole square. And you take the square root of that. Find the distance. You can call this as x1 y1. Call this as x2 y2. I see root 12.5. That should be right. So let's check that. So both of them will give 6.25, 6.25. So 6.25 is nothing but square root of 6.25 plus 6.25 will be 13. So d equals square root of 13. Okay. Same way, if you have to find the distance between the lines, you'll have to drop the perpendicular. Okay. So you have to drop the perpendicular and find the distance. Okay. I chose this because this was the simplest point where I think they are perpendicular, but we may give you this perpendicular and the coordinates. You'll have we may give this perpendicular line if we ask these type of problem, so that it's not confusing. So negative 3 comma 1. So the same way, all of you find the distance between negative 3 comma negative 1, and here I have 0 comma negative 3. Find the distance between these two. Negative 3 comma negative 1. Let me use different color. Okay, I'll give you another minute. Find the distance between those two points. To get the distance between the line. Well, my bad, guys. On the previous one, it was 6.25 plus 6.25, right? So it should be root 12. I thought it was 6.5. So I said 6.25, but so it'll be 12.5. Okay, that was the previous one. So please complete this one. I've given the coordinates. Find the distance. Mia and Kira were right. So let's check this one. I see root 13 from Kira from B to A. So here I have distance as square root of, let me call 0 plus 3 whole square plus negative 3 plus 1 whole square. So that will give us 0 plus 3 whole square is nothing but 3 square is 9 Negative 3 plus 1 is negative 2, and negative 2 whole square is 4. So 9 plus 4 is square root 13. Okay. Okay, let's see the next one. Move to the next slide. We will see a few proofs. We have been given that angle 1 is congruent to angle 2, and we need to prove that P is perpendicular to Q. I'll do this by 2-column proof. So I have statements on the left and reasons on the right. And every step has to be numbered. So first step always we start is what is given. From the figure we can know that these two are linear pair. So I can say that measure of angle 1 plus measure of angle 2 equals 180 degrees because of linear pair postulate. We know they are the linear pair from the figure, so I can say linear pair postulate that they will add to 180 degrees. I have measure of angle 1 equals measure of angle 2. This is angle congruence definition, because angle 1 is congruent to angle 2 whenever measure of angle 1 equals measure of angle 2. So the next step is I can substitute and get measure of angle 1 plus measure of angle 1 equals 180 degrees by substitution property. And I have, this means 2 measure of angle 1 equals 180 degrees. So I divide by 2 and get measure of angle 1 equals 90 degrees. I divided by 2, so I'll just tell division property. And I also have measure of angle 2 equals 90 degrees by substitution once again, substitution property. So if we have two angles are 90 degrees and they are linear pair, then they will be perpendicular. So by definition, we can say definition of perpendicular line, we can say that P is perpendicular to Q. Okay. Okay, let's see the next one. For the next one, what I'll do is I'll give you chance to get the steps of the proof. I'm going to ask you to fill up the blanks for reasons or the step, any one of them. Okay, so first, same way, I'll just write statements. And then the reason. Okay, fill up this reason. Then fill up this reason. Then fill up this reason. Please number your reasons. I'll check them as I'm writing the steps. So whenever you have the reasons, please number them. And that particular reason as well. Okay, same result will work for here as well. Actually, I could have copied 7 and 8, but it's the same reason that you'll need. Both together, I can say seventh step. This itself is seventh step. Okay, I don't need separate reason for this one. Just look for your reasons via chat and see what we have. First, I see given, second definition of vertical angles, then definition of right angle. So let's see, they are right. So this is given, that's absolutely right. It was given. Angle 2 is congruent to angle 3. Definition of vertical angles, better to say vertical angle pair postulate. We studied vertical angle pair postulate. which makes them congruent. Then definition of right angle for third one was right. So let me check for the others. I want all of you to participate, not just a couple of them. Definition of supplementary angle from Emma, but how do we know they are supplementary? That's right, definition of supplementary. But before that, we know that linear pair, right? So it's more of a linear pair than just supplementary. So I'll use linear pair than supplementary here because we know angle 1 and 2 are linear pair. So I'll just use definition of linear pair. Linear pair says definition of linear pair, and then if you want to add, you can also add some definition of linear pair and supplementary both together. Okay, but just don't put only one of them, but mention both if you feel definition of, because they are linear pairs. And from linear pair we know that they are supplementary, and from supplementary we know they add up to 180. Definitions of linear pair and supplementary. So I'll give both the reasons. I saw fifth one was someone had said substitution. So let's see. That's absolutely right. I'm substituting angle 2 equals angle 1. Substitution property I'll have. I substituted angle 2 equals angle 1. Because of this one, I can just substitute angle 2 equals angle 1, and I'll have 2 times measure of angle 1 equals 180 degree. And I had also seen a division property for sixth one. So division property is right. Okay, if you have the answer for the last step as well, so seventh one, you can use couple of things, not just one thing to get that. Okay. Okay. What am I doing here? I'm just substituting that. I know that their angles are congruent. If angles are congruent, then the angle measures will be same. If angles are congruent, we know here angle 2 is congruent to angle 3, angle 1 is congruent to angle 4. I'm using both substitution and definition of angle congruence. Definition angle congruence, I'll get this step. And then after that, I have to apply substitution to get this part. I've just clubbed in both the things in same step, but you could have written them in separate step. First it told definition of angle congruence, and I've just written these two, and then later on you could have written, let's do that way if you're getting confused. Definition of angle congruence. Then last, I can apply substitution and get that last step, which is nothing but measure of angle 1 equals measure of angle 2 equals measure of angle 3. That in turn equals measure of angle 4, which is equal to 90 degree. We can get this by substituting. Substitution property. Okay, this was a proof for this particular problem. Let's see the next one. Perpendicular line theorems. There are a couple of theorems which you have to keep in mind. If two lines intersect and form a linear pair with congruent angles, then the lines are perpendicular. So this is a theorem. Okay, perpendicular line theorems. There are a couple of them. If I have two lines, they intersect and both these lines are perpendicular. Okay, two lines intersect to form linear pair with congruent angles. If these two are congruent, then automatically they'll be perpendicular and you'll have a 90 degrees. Okay, these two angles are congruent, then they will end up being 90 degrees because linear pair add up to 180 degrees. Supposing if I was having a lines intersecting in a manner such that here they don't look perpendicular, but they are linear pair. These two angles are linear pairs, but they are not congruent. But if they are congruent, then they'll end up being 90 degrees because they add up to 180, and we will have 90, which will make us these two lines perpendicular. So that's what the perpendicular line theorem says. Let's see the next one. If two lines are perpendicular, then they intersect to form four right angles. Okay, if two lines are perpendicular, if I have two lines that are perpendicular, we proved that in the previous slide. Two lines are perpendicular, then they end up getting us all four angles to be right angles. So if this is given, these two lines are perpendicular. If these two lines P and Q are perpendicular, which will in turn make all these angles also right angle. Okay, that's the second theorem. Two lines are both perpendicular to the same transversal if and only if they are parallel to each other. Okay, if I have these two lines and this is a perpendicular to both of them, if this line, so let me call this line first one P, Q, and let's call this as R. If R is perpendicular to P and Q, then automatically this is true only when these two are parallel. The lines P and Q are parallel, only then we will have this particular R line to be perpendicular. If it is perpendicular to one of them, then it's perpendicular to other one also if these two are parallel. Okay, two lines are both perpendicular to the same transversal if and only if they are parallel to each other. Okay, let's see the next slide. We are going to prove the last one that we had. They have given us that P is perpendicular to A and they have given us A is parallel to B. We need to prove that P is perpendicular to B. And it's quite simple. So you have here statement and then reason. We have A is parallel to B, which is given. First step. Okay, and we are trying to prove that I haven't labeled this correctly. So let me label this so that you can get the proof easily. Let me call this as A, some point A over here. Let me call this point as B, and let me call this point as C. Let me call this as D, E, F. Okay, observe here, if these two lines are parallel and this is a transversal, if this is right angle, then this also will be right angle by corresponding pair postulate. Actually, from this is given, and from the figure we have from the figure, or you can mention that also as given. Measure of angle ABC equals 90 degrees, which is also given. Okay, and you further have angle ABC. You have to tell me the reason for this. Use your chat. Angle ABC is congruent to angle BDE. What is the reason? You have studied previously. So tell that. And angle BDE equals 90 degrees. That is 90 degrees. Got to tell reason for this step as well. Then I can say that last step, which was P is perpendicular to B. Use your chat and tell the reason for these three steps. Okay, just going to see what you have. Use your chat real quick and tell what should be the reason for last three steps. I want you all to participate. So I have corresponding pair postulate, corresponding angle pair postulate. Absolutely right. Corresponding angle pair postulate. I can say angle ABC is congruent to angle BD. Okay, how about the next reason? Reason for the fourth and fifth step. When these two are congruent, I'm just using substitution here, substitution property. This is definition of perpendicular lines. I have an angle definition of perpendicular lines. Okay, I hope I'm clear. Let's see the next slide. Okay, I think that's it for today. And for asynchronous time, I want you all to log into Hub and complete the assignment which is there, writing equations of lines. Okay, complete that, and by tomorrow you should be able to see the answer keys for the other assignments as well. And you also have the review, so go over the review. In the next class, I am planning to give you tests on this particular unit. Okay, you have rest of the time to work asynchronously on this particular assignment.